Welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 10 from the October-November 2019 Pure Mathematics P1 Cambridge 9709 syllabus. And this question here is all about differentiation and integration mainly. And the question here tells us about a curve for which d squared y dx squared is equal to 2x minus 5. And it has a stationary point at 3, 6. Find the equation of the curve. All right, so first of all, what does this mean, d squared y dx squared? Well, basically, it means a second differential. So you start off with a function y. If you differentiate this function with respect to x, you end up with dy dx. And if you differentiate dy dx with respect to x, you end up with d squared y dx squared. So this is the original function. This is the gradient function, and this is the second differential. If you're given it in terms of f of x, this would be f of x, this would be f dash of x, and this would be f double dash of x. Not minus one, no dash. Okay, so this is the original function, this is the gradient function, this is the second differential, which tells us about how the gradient is changing. So if we go this way, we have to differentiate. If you want to go that way, we have to integrate. Okay, if you want to go this way, you have to differentiate. If you want to go that way, you have to integrate. In this case, we have to find the equation of the curve. So we have to end up with y equals some function of x. We have to end up with this. So we have to go from here to here. So we have to do some integration here. All right. Now, when we're integrating, we normally have a constant of integration. When we're integrating, we normally have a constant of integration. For which, to find that constant, we need to have a pair of values, okay, which will help us to find the constant of integration. And by them telling us in this question that this curve has a stationary point at 3, 6, they have told us two bits of information from this. One is that 3, 6 is on the curve. 3, 6 is on the function, on y. So therefore, when x equals 3, y has to equal 6. So that's a pair of values we know for when we find the function y equals f of x, right? When we finish the integration, that's going to be the pair of values that we'll use in the end to find the original function. But because it's a stationary point is a point of zero gradient. At the stationary point, the gradient function is equal to 0. A stationary point could be a maximum, that point the gradient is 0. It could be a minimum, that point the gradient is 0. It could be even a point of inflection, that point is gradient is 0. So the second bit of information we can derive from this statement here is that when x equals 3, dy dx equals 0. So these two bits of information are key for us to be able to find the equation of the curve without having any constants like as variable as letters. To actually find the value of those actual constants, we need this information. So let's start off with what we have, d squared y dx squared equals 2x minus 5. So the first step is to integrate this. So to find dy dx, I've got to integrate this. So I'm going to integrate with respect to x, 2x minus 5. All right. Now, there's two ways we can proceed here. I'm going to show you both ways, side by side. One way is where you integrate and you just write things. You write plus c at the end, which you must do. If you're doing this as an indefinite integral, you must write plus c. So when I integrate this, I've got dy dx equals, I have to add 1 to the power, so it's 2x squared divided by the new power divided by 2. Minus a constant, just gains an x, so it's going to be minus 5x. You must put plus c at the end, right? And then when you put plus c in the end, you know, as we mentioned, the point, what was it? The point 3, 6 is a stationary point, which means it basically is a point on the curve. So when x equals 3, I know, sorry, this is for later. We know, because we don't have y, we have dy dx. We know that when x equals 3, dy dx equals 0. That's what we're going to use first. So when x equals 3, dy dx is equal to 0. So I can say 0 is equal to, this is going to be x squared minus 5x plus c. So 0 is equal to 3 squared minus 5 times 3 plus c. So that's going to be 9 minus 15 plus c. Now 9 minus 15 is equal to negative 6. So 0 is equal to negative 6 plus c. Therefore, c is equal to 6. So we can say now that dy dx is equal to x squared minus 5x plus 6. So we've got that far. Now we've got to continue, but I'm just going to stop on the way to show you on an alternative method. The way that I personally prefer to do this type of question is, as we know, that when x equals 3, dy dx equals 0. So at this stage, I'm going to say, okay, I want to find, I'm going to write this out. This is the integral of 2x minus 5 dx. So I've got my dy dx here. I want to find what dy dx is, okay, in terms of x. I want to find what is dy dx in terms of x. I know that when dy dx is 0, that's when x equals 3. All right, so I can now, when I integrate this, I can have, this will be dy dx. So I'll replace dy dx with dy dx, and I'll replace dy dx with 0, so minus 0 is equal to, then I have this as a definite integral, so I'm going to have still x squared minus 5x. I don't have to put the plus c now because I've got these definite integral here. So this will automatically find the value of c, as you will realize. So this will say dy dx is equal to, now I'm going to put x instead of x squared minus 5x, so it will be x squared minus 5x. Then I'm going to take away what happens when I put 3 instead of x squared minus 5x. That's going to be 3 squared minus 5 times 3. So you end up with dy dx equals x squared minus 5x. And then you're going to have minus, that's going to be 9 minus 15, which is minus 6. So you end up with dy dx equals x squared minus 5x plus 6. So we get the same answer up to now, whichever one of those two ways we choose. Okay, so this is, one method, and this is an alternative method. Both of them give us the same. All right, now, we haven't finished. That's not the equation of the curve. The equation of the curve is when we found y. So we want to find y. Now, we know that the point, as we said, the point 3, 6 is on the curve. So 3, 6 is on the curve. That means when x equals 3, y equals 6. So if we integrate dy dx, so we integrate x squared minus 5x plus 6 with respect to x. Okay, that will give us y. So y equals, it's going to be x cubed over 3, add 1 to the power divided by the due power, minus 5x squared over 2, plus 6x, and if you're going to use this method, plus c. Then we can say that when y equals 6, x equals 3. So that's 6 equals 3 cubed over 3, minus 5 times 3 squared over 2, plus 6 times 3 plus c. So you're going to have 6 equals, that's 27 over 3, which is 9, minus, that's going to be 5 times 9, 45 over 2, plus 18 plus c. So let's just work that out. Where's my trusty calculator gone? Here it is. Oops, it's disappeared. Okay, so you're going to have here 9 minus 45 over 2. And we're going to have plus 18. That's 27 minus 45 over 2, which is 9 over 2. So you have 6. 6 equals 9 over 2 plus c. Therefore, c is equal to 6 minus 9 over 2. That's 12 over 2 minus 9 over 2, which is 3 over 2. So therefore, we can say here that the final equation y equals 1/3 x cubed minus 5 over 2x squared plus 6x plus 3 over 2 is our final equation. That's the equation with value of the constants that we found now by doing double differentiation, double integration. Now we can also do this using this other method that I personally prefer, as I said. We can take this and we can integrate this with respect to x. So we'll end up with y equals the integral of x squared minus 5x plus 6. Okay, so if I integrate, so I want to find what y is in terms of x. I know that when y equals 6, x equals 3. So this will automatically find the value of c for me. So when I put y into here, I don't have to integrate. This has already been integrated when I put dy dx as y. So you have y minus 6 equals, now this side I need to integrate, which gives us the same expression as this, x cubed over 3 minus 5x squared over 2 plus 6x. I don't have to put the plus c because I've got my limits here. This will automatically find what my c is. So you have y minus 6 equals, this is going to be x cubed over 3 minus 5x squared over 2 plus 6x minus, I'm going to put 3 instead of the x, so it'll be 3 cubed over 3 minus 5 times 3 squared over 2 plus 6 times 3. So this will give us basically 9 over 2 on this side, won't it? It'll be 9 over 2. So you have y minus 6 equals x cubed over 3 minus 5x squared over 2 plus 6x, and you'll end up with minus, that'll be 27 plus 18 minus 45 over 2. That's going to give you minus 3 over 2. Minus 3 over 2. Not minus 9 over 2, sorry. That gives you minus 9 over 2, as we found earlier. Okay. Yeah, that's 3 cubed over 3. That's 9 minus 45 over 2, which was this, plus 18, 9 over 2. Okay, so therefore y is going to be x cubed over 3 minus 5x squared over 2 plus 6x minus 9 over 2 plus 6. So it's exactly the same as this. Okay, you end up with y equals the same thing. It's going to give you exactly the same as this, because this is like 12 over 2 minus 9 over 2 is 3 over 2, so you end up exactly with the same thing. A third x cubed minus 5 over 2x squared plus 6x plus 3 over 2. So whichever way you prefer, whether you like to use plus c's or whether you like to use the limits, as you wish, you should end up with the same answer. And that concludes part 1 of this question. Part 2, it says, find the x-coordinate of the other stationary point on the curve. So the stationary point is a place where dy dx equals 0. Now we know one of the stationary points was when x equals 3, okay, and because it was a point 36, right? So I know that when x squared minus 5x plus 6 equals 0, that's when I'm going to get the stationary point. So there's another stationary point, so to find it we can factorize. I know one of the factors must be x minus 3, because in the end you have x equals 3, that's one of them. And the other factor, of course, therefore must be x minus 2. We could just factorize it straight away. You will notice that, of course, one of them has to become x equals 3, otherwise we've done something wrong with this. So that's the one thing that we can rest assured that we've actually done the right thing up to that point, at least in the last question. So x equals 2. So the other stationary point is when x equals 2. So when x equals 2, it says find the x coordinate. Okay, again, reading the question is important. It says find the x coordinate. So up to now, that's all they wanted. All right. If it said find the coordinates, you would then put x equals 2 in here and find the y coordinate as well. But here, they just want the x coordinate. So the x coordinate is x equals 2. That's the answer to part 2. It's only worth 1 mark, as you can see why. Then it says part 3, determine the nature of each of the stationary points. Now to determine the nature of the stationary points, we need the second differential, which we have as 2x minus 5. Okay, so if we have d squared y, dx squared equals 2x minus 5, that will help us determine whether the stationary points are maximums or minimums. We could also do that by knowing that this is a cubic curve, because we see the curve is y equals a third x cubed minus 5 over 2 x squared plus 6x plus 3 over 2. So this is a familiar type of curve. We know that this has got a positive x cubed, so it's going to have a maximum before the minimum. So I know that x equals 2 is a maximum, and we know that x equals 3 is a minimum. Why? Why do we know that? Because as I mentioned, this is, you can say the nature of the cubic curve. In the curve, when you have ax cubed plus bx squared plus cx plus d, okay, then when a is positive, when a is greater than 0, the maximum is before the minimum. That's one way you could answer the question. Another way is you could use the second differential. So when x equals 2, d squared y dx squared is going to be 2 times 2 minus 5, which is going to be negative 1. So therefore, d squared y dx squared is a maximum. is a maximum. All right. The reason why, because when you have a maximum, the d squared y dx squared tells us how the gradient is changing. The gradient is going from a positive gradient as you go along to a negative gradient. The rate of change of the gradient is negative because the gradient is decreasing the whole time. Positive, 0, negative. So when you have a maximum, you have the second differential will always give you a negative value, okay, at the maximum turning point. At minimum turning point, when in this case x equals 3, you'll see what happens. The second differential is going to be 2 times 3 minus 5, which gives us plus 1. So therefore, d squared y dx squared as it is, here what I should write here, I should write this in a better way. I can say as d squared y dx squared is less than 0, therefore x equals 2 is a maximum point. Okay, and here as d squared y dx squared is greater than 0, therefore x equals 3 is a minimum point. Okay, because when you have a minimum point, what's happening to the gradient? It's starting off negative and it's becoming positive as you go along. So the gradient, the rate of change of the gradient, d squared y dx squared, is going from negative to positive, so it's increasing. So it's a positive value. So when the second differential gives you a positive value, that's for a minimum point. When it gives you a maximum value, when it gives you a negative value, it's for a maximum point. Okay, and there's the answer to part 3. I think that was it here. Yep, that was it. So that's the answer to this question. Okay, now this first method here would only be true if we know the nature of the curve. It's cubic, we know how cubic looks. Either it's like this or it's like this. If the x cubed positive coefficient, it will look like this. If it's a negative coefficient, it will look like this. So in this case, the maximum comes before the minimum. In this case, the minimum comes before the maximum. So the lower value will be the maximum and the bigger value will be the minimum. But if it was any other function which we didn't know what it looks like, or it's not a standard type of function like quadratic or cubic or something that we're not sure how it looks, then this is the go-to method where you substitute the x values of the turning points into the second differential and see the sign. Okay, so that concludes this question here, which is all about, I say, it's a mixture between integration and differentiation. So at the end of the video, you'll find a playlist linked at the top of the page, which will take you to this paper. Any questions I've answered from this paper will be in that playlist. And then you'll have here another link which takes you to the topic of integration from my P1 material of Cambridge. And over here, you'll be linked to another playlist which will take you to my differentiation material under Cambridge, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.